Page 5, number 10, in the notes, we got our derivative last time, that e to the negative x times negative x plus 1. We made the number line. We talked about how the e to the negative x is always positive. Hopefully this sounds a little familiar from Friday. So all that matters when we're dealing with the sign is the negative x plus 1. Plug in there. We've got our regions. So what is happening at x equals 1? Someone said something that I couldn't hear. Maximum. There's a maximum, relative max, at 1 comma. Where do the y-coordinates come from? Original. 1 comma 1 e to the negative 1. Maybe you got this part last time. Maybe. Should be 1 comma 1 over e for the maximum. Then we need to deal with our points of inflection, which means we need to look at f double prime. I think it's going to be easiest if you take this version of your first derivative and find the derivative of that. So I won't have like the parentheses to deal with. Go do that. Find your derivative of the negative x e to the negative x plus e to the negative x, and then do some simplifying to it. If you do this properly, it will end up being a nice looking derivative. Something that'll be easy enough for us to work with. You need to be using product rule on negative x e to the negative x, chain rule within that. I think you disagree. Maybe. I don't know. Oh, because you're trying to tell me negative x times negative 1. Yeah, I guess. If you want. Okay, we'll make that positive. And then we can factor out an e to the negative x. See if you can finish everything. It's going to end very similar to our increasing, decreasing stuff. Make your number line, test the regions, realize how to work with that e to the negative x. What are your signs? What's before 2? Really? No, sorry. Yes, of course. Right. If you plug in 1, this is negative. This is always positive. Yes, that is negative. This is positive. And we have a point of inflection at 2. Comma 2 e to the negative 2, but we shouldn't say that. We should say 2 comma 2 over e squared. Questions on that? Next thing. In number 11, we want to figure out where f of x is decreasing, and I gave you f prime. So start by finding the derivative. Does that sound good?
No,
you already have the derivative. So basically, I already gave you what you need to use to make your number line. See what you can do. This is a non-calculator question, although as you're doing this, you're welcome to have those strips of the graphs out. That may help with some values, although of course we won't have those in the test. See what you can do, because I already gave you the derivative. Question? Well, to find the critical values, we need to figure out where the derivative is 0 or undefined. So let's set the derivative equal to 0. You need to go and solve that equation. Getting 3 for a critical value. And I should include domain things somewhere on here. And by that I mean, what's the lowest that x could be, but maybe not even be? Where will my boundary be? Well, it's going to be when the stuff inside the natural log is 0, which means x is going to have to equal 2. Because if x was 2, then you'd get your 0 inside the natural log, and then we have problems. So now you have 2 regions. Go test them. What do we think? What letter? I like that. Plug in 2.5. Natural log of, well, that becomes 0.5. Natural log of 0.5 is something negative. So mark that as negative. Plug in maybe 4. Natural log of 4 minus 2. Natural log of 2 is something positive. So I'm decreasing between 2 and 3, which is what I was looking for. And we'll go with letter A for this one. Yes. Yep. That's exactly what I'm thinking about. Natural log of 2.5 minus 2 is the natural log of 0.5.
I was looking at the natural exponential function.
Natural log. Take a look at number 12. You're going to do points of inflection, but I gave you a second derivative. Do we actually need to test the regions? What's our definition of a point of inflection? Where, no, not it. So in this case, where h double prime changes sign. So do I need to test regions to see that? Sure you do. Just figuring out where the second derivative is 0 isn't good enough. So see what you can do. Is anything going to come from that first piece, the e to the x minus 1? No, e raised to anything is always going to be positive, so I don't have to bother with that. And this also means when I go to plug in to test things, I don't have to bother with that. I'm just going to focus on the polynomial stuff. Oh, actually, I feel like there's another piece I don't have to even bother plugging into. What am I? Yeah, the square thing is always going to be positive, so I can kind of skip over that and really just focus on those. So anything to make this a little bit easier with the plugging in, I'll take those shortcuts. How many points of inflection? There should be 2. To the right of 3, I'm going to ignore those first 2 parts. This is positive, so that's positive. Plug in maybe 2. This is negative, this is positive, so that's going to be negative. Plug in 0, this is negative. This is positive, so that region's negative. Plug in negative 2, this is negative. This is negative, so it'll end up being positive, and you've got a point of inflection at negative 5/4, 1 at 3, and nothing going on at x equals 1/2. Anything there? Number 13, honestly, I could have given you before we even knew things about e to the x. I'm telling you the derivative, want you to tell me where there's a relative max, and this is a calculator question. So you're going to want to use your graphing calculator. Say that again? The last one was not. This one is, though. And I think you have some solving by graphing work to do. What are we looking for to have a relative max? What's the definition of a relative max? F prime changes from positive to negative. I gave you the formula for f prime. So what are you looking at when you graph it? The y values, the slope? Where the y values change from positive to negative. Go see if you can figure that out. Maybe you can use the multiple choice answers to kind of set your x values, at least for your window. I'm going to go from maybe -1 to +4 because that's all the values that I see over there. Well, we're going to pretend that. I think it should kind of look like this. Is this what I care about? No. How about this? Yeah, because this is f prime, and that's where the f prime values are changing. So second calc, find the 0. Maybe. That seems reasonable. So maybe letter C? Maybe.
That's what I got.
Number 14. And then we're going to move on to particle motion. In number 14, we want to find a point of inflection. I gave you f prime. There are 2 ways you can do this. One is a little bit annoying, one's a little bit easier. What's the definition of a point of inflection? Okay. The annoying way to do this is I can go and I can find my second derivative and then graph it and look for where that's changing sign. There's an easier way. Graph f prime and look for where f prime is changing its slope. That might be easier because then you don't even have to bother calculating a derivative. I would just do that. They gave you an interval to focus on, so make sure you set your window appropriately. Also make sure you're in radian mode because there's trig in there.
So
This would be a graphing calculator question. So hopefully the graph looks kind of like this for f prime. And should I now go try to find this point over here? No, that would be a relative maximum where f prime is changing from positive to negative. You need to find that point. Second calc max, exactly.
please don't spoil it.
Oh, good. And what's the answer? Letter B. Questions here? The homework will note where you should be using a calculator and where you shouldn't be. Please don't do the stuff without a calculator. With a calculator, otherwise you just won't get the practice you need for that test on Thursday. Particle motion. I think I want to start with number 16 just to make sure we get through all that. If we have time, we'll go back and do 15. But I do want to look at 16. And I need a copy of this. Please take a moment and read number 16. There's a lot going on there. We'll come back to 15 maybe. Two particles, why not? Why not? Nope. Oh my gosh. I was going to actually put 3 on here, but decided to limit it to 2. Haven't finished the test yet, maybe. I'm getting ideas. Okay, here's the good news. Yes, there's 2 particles in this problem. Each part, basically, other than one of the parts, only deals with one of them at a time. So it's not actually going to be as bad as you think. Hold on. Part A. At time 1.5. Wait, what's wrong? Oh, that is a typo that we need to fix. It should not say velocity. Please change that. I labeled it correctly. I called it the wrong thing. It should say an acceleration. Thank you. That was deliberate. It was not supposed to be called velocity. Now we fixed it. It will be fine. Part A. We want to figure out, at 1.5, is particle A moving left or right? Okay, we've got to kind of get back those definitions of things. What about velocity? Okay, so let's find the velocity at 1.5. How difficult should it be to find the velocity at 1.5?
Not hard at all.
Because I gave you the velocity. So you need to go and you need to find v sub a of 1.5. This would be a calculator question. Yes, so please go plug in. Again, make sure you're in radian mode. And then we'll deal with the second half of this problem. What's the rule? 3. And yes, let's give the number and then let's reach our conclusion. Ari, what's the number? So what does that tell us?
It's moving to the left.
Moving to the left. We shouldn't be graphing anything. We should just be plugging in. Moving left because the velocity at time 1.5 is negative. Then, are we speeding up or slowing down?
Well, we have to determine that based on when A is 1.5.
Okay, so we need to look at the acceleration and velocity at the same time. So, just plug into your acceleration formula? What's wrong? That's for B. You need to find the acceleration formula. So, the acceleration of particle A at time t equals, well, go find your, what are we doing, integral or derivative?
No.
I guess we could do that. I do want you to actually calculate the derivative because we're going to need it for some other things later, and that's all I have to say. Yes. That would be product rule. I think we'll need it for other things later.
When just writing cosine comes before B, and like do the trig come before?
It doesn't really matter, I guess,
Okay.
as long as it's clear that like the e part won't be inside the cosine. And by the way, you're using product rule, but I hope there's also chain rule involved with this.
Yes, sir.
That's totally wrong. I'm going to try that again. And I don't really think it needs to be terribly simplified because we're just going to plug into it anyhow. So after you found it, do some plugging in and then get your conclusion.
And then we do
And then you plug in 1.5 that same time when we found the velocity. We shouldn't really need to be graphing things. No, if you said, yes, we're not giving the exact answer, so yes, I'm using that. If you use equals, they will not take off on the AP exam. Do we have an acceleration? What is it? It should be kind of big. 50 something. 50 point.
4, 3, 5.
Are we speeding up or slowing down? So it should have asked you to justify this. I'm going to say slowing down because the velocity at 1.5 and acceleration at time 1.5 have opposite signs. Bless you. Anything with part A? Part B. The initial velocity of particle B is -1. Find the velocity at time 1.3. Do we have a velocity formula for particle B?
No.
How could you create it?
Integral of A.
Okay, that's what you're going to need to do. In part B, the velocity of particle B is the integral of the acceleration of particle B.
So what was that rule when it actually says equals the integral? We have to use that colon.
That was when we were creating our own functions defined by integrals. Find f of 4. Well, this integral equals f of 4 minus f of 1. And if you said equals, it would be like f of 4 equals f of 4 minus f of 1, which isn't true. No. Here is perfectly fine. Honestly, the rest of the work in this part is exactly what we did last time with those initial value problems. So see what you can do. I do want you to give an exact value for C. But then when you go to actually find your final velocity, we can just give decimals for that. I would. And I hope that there's going to be use substitution involved in your work. There should be. Because I told you the velocity at time 0 is -1, you'll plug in. You'll figure out your C. I'd like C to be exact, but when you finish off the problem, then give decimals for the final answer. And C is going to be messy, and that's fine. There's going to be natural logs in there and stuff. That's okay. Well, again, I want the C value to be exact, but the final answer, give a decimal. what are we getting as a decimal for the position? Okay, keep going. What do we have? Someone must have a number. Nicole, do you have a number? What do you have? Well, that's what I got when I did this one. So we should have negative 4/5 times the natural log of, we just need parentheses, not absolute value, because this is a positive thing, but 12 minus 5 times 1.3 in the parentheses. Close them. Then plus 4/5 times the natural log of 12. Close those parentheses, and then say minus 1. And that should do it. I would like you to try to do letter C. Read C. Try to do it. And yes, you'll need your calculator. Yep. So I want to know when they have the same velocity. Well, like, what are we really doing? You're right. Setting them equal. So I want to say the velocity of particle A equals the velocity of particle B. I would, right?
Yeah.
I would probably just graph them and then do something with that. By the way, in the original problem, it said this is good over the interval from 0 to 2 in the very beginning of the original problem. So set your window appropriately between 0 and 2. While you're doing this, please just remember the rule of 3 decimal places for all these things. Find the time or find the times. I guess it doesn't matter in this case. In other cases, yeah, we will need to find the absolute value function.
Wait, what are the,
Yep. So when you're going to type this in, this probably isn't going to work. But if you push math, go over to the number menu, and then it's option number 1, ABS.
Okay.
So in this case, because we're just looking between 0 and 2, no, it won't matter. If we were looking between 0 and 3, we would definitely need them. Because if you plug in 3, 12 minus 5 times 3, you're going to get a negative 3 inside your natural log. And yeah, we would have to take the absolute value.
So you put on math?
Math, number, and then it should be the first option there. I am thinking there should be two answers. Two answers, maybe? Possibly?
I got 0.601.
Hold on. Hold on. Some people are still going. Katie, do you have the two answers? Okay, well, let me take a look at your graphs.
I did.
We've got to find where they intersect. Second count intersect?
I got very similar numbers.
And we're looking for the x values? Yeah, you would have, which means you found the velocity, but not the time when they did those things. Yeah. Problem? Back up.
It's just very slightly off. I'm just gonna add in a couple more parentheses here and there. Toss a few and see if that does the trick. I believe it over there.
Exactly. I want to get, you can add a picture. I want to add a picture like my name is like,
Does anyone else need me to take a look at their calculators? Do you have a question about your calculator?
No, I don't.
I'd like you to try to do letter D. See what you can do in D.
Oh, wait, that's fine.
Or you can solve by hand. That's not terrible. Cross multiply. Find the speed of A when B's acceleration is 0.8. So how should we start?
Plug it into,
What do you mean by plug in?
plug it into the equation that was given to us for acceleration of B.
Like set the acceleration equal to that?
No, like plug it in for T. No, I mean set it equal to
Thank you.
and then find
Every
T.
single time I graph it, it's more wrong.
Okay. I will be over in just a moment. I would probably solve this thing by hand. And then you'll have your time, and then you can do something with that.
Oh, like the right. Yo, last night I was at like a
We should have a -1 inside the natural log.
It's gonna get confused with the rest of it.
Well, but it's not inside the natural log. I hope we're working. I don't think so. I think you already have it working.
For speed?
Well, what is speed?
I was thinking
Negative 8.062.
No.
It's really wrong. It's worse than.
That's what I got.
No, you're wrong.
Wait, I got the right one.
Yes, sir.
Yeah.
Yes, sir.
It's a positive 8.0. Right, speed is just.
Yeah, well, you were wrong.
I got 40.
Oh, I didn't.
No,
hey, what you say?
Try that again. Okay. What's the time?
1.4.
1.4. I would cross multiply and solve to do all that stuff. I said 9.6 minus 4t equals 4. Negative 4t is negative 5.6. T is going to be 1.4. Your velocity is e to the 2 times 1.4 times the cosine of 1.4 times 3. And I'm getting negative 8.062, which I told you was not correct. Speed is the absolute value of velocity. So our speed is going to be about positive 8.062. That's what should be happening. So a couple things. Your homework is to finish that packet. You're going to do 9 through 20, which will be curve sketching and particle motion. Next time is our review days. So we'll probably look at a bunch of AP things. We'll probably do a few other things. Test on Thursday. In addition to the homework, do start moving through that review packet. And the cumulative review.